and welcome to another 5-minute video aimed at the Level 3 Technical Certificate. Today we're going to look at some definitions, and we're going to start off with the definitions and understanding of sensible and latent heat. What do we mean by sensible heat? Do we mean heat that's got some sort of intelligence, that's clever, that's got common sense? No, we don't mean that. What we mean by sensible heat is heat that can be sensed. In other words, if you put a thermometer in it, a mercury thermometer or an alcohol thermometer, if there's a change in temperature, then the level of the alcohol or the mercury moves. If you put it from a normal environment into a hot environment, the mercury will go up. If you put it into a cooler environment, the mercury will go down. So we can see that there's a temperature difference, so we can sense that there's a difference. Latent heat's a bit more difficult. You can't see latent heat, you can't put something in and measure latent heat. You can only really calculate what the latent heat is. And because you can't directly determine it, then we call latent heat hidden heat. So before I go on to explain about latent heat, let's just look at the 3 states of matter just to get an understanding of what's going on. First of all, we've got solids. Solids are molecules that have got the least amount of energy. They're in a particular shape and they stay in that fixed shape. Nothing will encourage them to change shape. They'll stay exactly as they are. Liquids, on the other hand, they've got a lot more energy than solids. And if you look at this liquid here, it takes the shape of the bottom of the vessel that it's in. And if we took that vessel and we turned it upside down, then the liquid would change shape to take the shape of the new bottom of the vessel. So liquids need to have a lot more energy than solids do. If we move on to gases now, we've got an empty bottle here, then that's filled with gas. So even without turning it around, the gas has to be able to fill every little nook and cranny of that bottle. So it's at the bottom and it's at the top, it's everywhere. So gases need the most amount of energy of all. Okay, let's finish with the states of matter. Let's get back to the idea of latent heat. Imagine we did an experiment, a nice safe experiment. Imagine we take some ice at minus 20 degrees C, we put a thermometer in and we watch it and we put it in a room at plus 20 degrees C. What would you expect to happen? Well, this is what you'd expect to happen. You'd expect to get this line here, and you would expect the temperature would rise constantly from minus 20 through to 0 up to plus 20. That's the prediction. Now when we actually do that experiment, surprise, surprise, that's not what we get. We get that bit okay, but then as soon as the water gets to 0 degrees C, something strange happens. For a while, absolutely no change in temperature. See? So time's going by, but it's still staying at 0. And then, a while later, it starts to increase again. And it increases parallel to what we would have expected in our initial ideas experiment. So what's going on? Well, in this first part, we've got what we call sensible heat. So we can sense the heat. The temperature is slowly increasing as predicted from minus 20 up to 0. At that point of inflection where the two curves meet here, what's happening is that the very first crystal of ice converts to a crystal of water, a droplet of water. So we're going through a change of state. We're going from a solid to a liquid. And as we said earlier when we looked at the states of matter, liquids need more energy than solids do. So where does the liquid get that energy from to become a liquid? It gets it from the heat in the system. So rather than the heat now being used to heat up the ice, the heat is now being used to convert the ice into a droplet of water. All along this system now, water is being formed, ice is disappearing. And at this point here, the very, very last crystal of ice is converted to the very last drop of water to be formed. And from that moment on, the water then continues to heat. So again, we can measure that. We can see the thermometer change. So this is sensible heat. The point in the middle here, this is the latent heat. This is the heat that, in this case, is taken in to convert the ice into water. If we look at it in paper making terms, much less of a safe experiment to do, rather than using ice and water, this is what happens in the paper industry. We're taking steam at a high temperature. It will cool down until it gets to, say, 100 degrees C. At that point, it will stop cooling down and all the steam will be converted into water. Once all the steam has been converted into water, then the water will continue to cool down. At this point here, because the steam is going from a gas to a liquid, it's giving out heat. And it's that heat that's given out that actually heats the shell of the drying cylinder that then heats the paper. So it's the latent heat here. This is the key to transferring heat from steam into any other object. It's making the steam condense, and it's the act of condensing that gives out the heat. It's not the steam itself. So in summary, what we've talked about today is sensible heat can be sensed directly with a thermometer. Latent heat can be calculated, but it can't be sensed. So latent heat involves a phase change. If you're going from a solid to a liquid or a liquid to a gas, you need to take in latent heat to give it that extra energy. If you're going from a gas to a liquid or a liquid to a solid, then you are giving out all that latent heat because you're reducing the energy needs of that particular item. Well, thank you for listening to this talk on sensible and latent heat. Hope you enjoyed it, and please feel free to follow us on any of this social media.